Okay. All right, might want to give folks a minute or two due to the.
Yeah, while we're waiting for people to join, I'm just going to share my screen. I've got a few slides to start off with, and then we'll dive straight into the templates and probably some practical examples on my local test setup. So can you guys see those slides? Have I shared the right screen?
It looks at the moment, Steve, like you're sharing both the slides and the desktop with your browser in it.
Okay, no worries. Let's see if I can fix that. How's that? Is that better?
Yeah, that's better.
It's better.
Okay, great. Okay, so it looks like most people have probably joined, so we'll get started now. So this was going to be a session primarily talking about the tripleo-heat templates. I was going to start with kind of some fairly basic introductory material, which will probably be familiar to some people on the call, but I just wanted to make sure we kind of get the basics sort of established before getting into the more complex stuff. I'll go over kind of just an overview of the template model we use, a bit of discussion around the new Composable services interfaces, and then for the second half of the call, I wanted to bring up a terminal with the templates in. We can walk through the code, people can ask any questions they have, and then I'll fire up an Overcloud deployment and we'll look at some of the heat software deployment happening live, and I'll go over a few of the debugging steps that I tend to use and some of the internals, which will help you when your deployments don't work first time. So I want this to be quite interactive. If there are questions on the way through, feel free to just stop me and we'll answer them as we go through. So the obligatory owl picture, no tripleo talk would be complete without a picture of an owl. So there it is. It's the original owl, not the latest one. So as many of you all know, we use heat templates extensively to deploy OpenStack with tripleo. And the one thing I wanted to point out is, unlike some of the sort of OpenStack DSLs around, I'm thinking specifically of YACL here, the heat DSL is quite well documented. We've got some pretty reasonable documents around the template guide and the spec for the template. So if you are working on the tripleo templates, that's always a good place to check out. There are some more advanced aspects which tripleo makes use of, which aren't so well documented. So I'm going to kind of focus on those as we go through this discussion. So the basis of any heat deployment is deploying a heat stack. And so you have a YAML template, which contains a number of resources, which represent either OpenStack resources, like a Nova server or a Cinder volume, or alternatively, a parent stack can reference a child stack. So we call that a nested stack. And that's a really powerful model for composition, that we make very heavy use of that in tripleo. So that's kind of just the sort of the basic concept to kind of keep in mind as we go through this. So I mentioned composability, and we use this all over the place in tripleo. And the nice thing about this is it allows you to obviously encapsulate chunks of related resources and the configuration, or things which are specific to a particular role. And you can use either the nested stack template name directly, or you can use a type alias. In this case, it's OS tripleo controller. Sorry, was there a question there? Nope. Just someone joining. So this is the interface in the sort of the template definition form. So you define a type for a resource, and in this case, it's called OS tripleo controller. So that type can either be one of the heat built-in resources, which might be like OS Nova Server or OS Neutron Port, and those are defined via heat resource plugins, which is some Python code that Heat has running on the Heat service side itself. But you can either override the Heat built-in resources or define your own arbitrary names by making use of this thing called the resource registry. And so if anyone's looked in the tripleo-heat-templates tree, you'll see there's Overcloud resource registry Puppet, and that's got an absolute ton of these type aliases like OS Triplo controller, which when you create a resource of type OS Triplo controller actually creates a nested stack, which is Puppet controller.yaml. And there's a symmetry there where if you define parameters inside your nested template, then you pass data to those parameters, typically via properties passed to the type in the parent resource. Or, as you'll see in a lot of the Triplo templates, you can also pass them direct via parameter defaults in the environment file. So we'll talk about that a bit more later. But the key takeaway is we make heavy use of this resource registry abstraction within the Triplo templates. I was just checking the chat there because it looked like there was a question. Okay, so when you create a heat stack directly via heat client, you do heat stack create, then the stack name, the name of the parent template, so the template.yaml, and then -e, and then an environment file. We pretty much use the same interface when you're creating Triplo stacks via Triplo client. So that's like OpenStack, Overcloud, deploy, and then you can do a -- templates, which points at a templates tree, and then you use the same -e syntax for potentially multiple environment files. So the interface for Triplo is not exactly the same. In theory, you could create a Triplo heat template, heat deployment directly via Heat, but it's more convenient to do it via Triplo client. So that's kind of the basics of composability. The other feature that we make really heavy use of in Triplo is grouping. And so basically, this is really handy when you want to create a bunch of resources which are exactly the same. And the obvious use case for that in the OpenStack deployment is creating a bunch of servers which are identical as a cluster. So a bunch of compute nodes, multiple controllers, multiple Swift storage nodes. And that's exactly what we use inside the templates to do that. You pass in a count, that's the number of controllers, and the resource group just goes through and creates multiple resources. So this is going to create one nested stack, which is OS Triplo controller per controller node as defined by controller count. One thing that's probably worth pointing out is that the OS heat resource group is also a nested stack internally. So that can be kind of handy. If you look at the ID of the resource group, when you do like heat resource list of the Overcloud, the ID, you can then do like any of the stack introspection operations. You can just use that ID as if it were a stack that you created via the command line. So the third concept, which is kind of crucial to understanding the Triplo templates, is our software configuration workflow. So we do make heavy use of Puppet, but we drive Puppet via Heat, and Heat provides some abstractions that enable you to encapsulate configuration, deploy that configuration on a server. And the way it basically works is the software config resource is the abstraction that wraps the config itself, including any input values or parameters that might be expected by that, say, shell script or Puppet manifest, or potentially Ansible playbook or chef recipe. The abstraction in the Heat templates doesn't care what tool you use, because the way it's actually applied is via a hook on the node itself, and that is the point which Puppet, for example, is actually applied. So the software deployment is the thing that actually changes the state of things on your server. So when you create a software config resource, it doesn't do anything. It's just like a store for your Puppet manifest, say. And then when you create a software deployment, it takes two input properties. One is a reference to the software config, and one is the reference to a server. The server is basically polling for metadata associated with deployments, and we use OS collect config to do that. It's a little Python daemon, that Python process that runs periodically. It polls Heat, via one of several transports that are supported, gets a list of deployments, and any that it hasn't already applied will then be applied via the heat config hook. So OS refresh config runs, which basically just is a way of running a script to trigger heat config, which is another script. And then that knows if you've got a software config that is defined as group puppet, we would then run heat hook puppet. And it pulls in the puppet manifest and any input parameters that could be either factor or higher variables, depending on how you configure things in the templates. It applies puppet, and then afterwards it sends back a notification to heat, and it uses a tool called heat config notify. Again, that's just a small wrapper script that knows how to extract the URL and credentials from the deployment metadata and signal back to heat. So this is something we use all over the place, and understanding that this is kind of the model we use for software configuration is kind of the key to understanding the AAA deployments, particularly when they go wrong. So going back to the resource group abstraction for a moment, we currently support 5 different roles. We're working towards making this sort of fully customizable, but as of right now, we create 5 resource groups containing each one of controller, compute, block storage, object storage, and Ceph storage. So once you've created the groups of nodes, you obviously need to configure them as a cluster. You can't just configure each node individually. You need to wire them together in many cases such that they can work together as a cluster. So there's 2 phases. The first is to do the individual node deployments. So as I mentioned before, the resource group will create a nested stack, which is, say, puppet controller.yaml. And inside there, we create a server, which is then configured on a per node basis. For example, configuring the network devices and deploying some data. Networking isn't a separate resource group. So no, networking isn't a separate resource group. There is a nested stack that creates the network architecture itself, which I'm not going to cover in the slides, but we can dig into once we start looking at the templates for sure. What we're talking about here is more you have a configuration for each node, which is like the IP addresses to assign to network devices, or the configuration for bridges and things on each node. So that's basically that's basically what we're doing at this stage. And there's a few other things.
So right now, your network controller, you can't have a separate network controller. It's going to be bundled up with the rest of your control services.
As of right now, yeah, but there are requirements. Several folks have expressed requirements around wanting to, say, deploy an SDN controller as a standalone node or group of nodes running some services that we don't currently directly support. I'm working on a blueprint which is called custom roles, and that aims to enable that. So basically, so going back to here, rather than just having, say, a controller resource group, you could also have like a custom controller group of nodes, which might be one or more nodes. Right now, that's not possible without hacking the templates, but we're aiming to try and finish that by the end of Newton. That's kind of the top of my to-do list right now.
Okay, thank you.
So this is the per node deployment, and then the next phase is we go through and configure all of the nodes in the group, potentially to do things like give the IP addresses for all of the nodes in the group to all of the other nodes so they can communicate and those kinds of things. And the way we do that is basically the same model that we use for sort of single software deployments, only there's an abstraction called OS Heat Software Deployment Group. This again is a nested stacks all over the place, and it just contains one software deployment per server. So if you've got 10 compute nodes or 3 controllers, it creates a corresponding number of software deployments inside the software deployment group, and that references only one software config, you'll notice, and that's because the software config, as I mentioned earlier, doesn't do anything. It's just a container for, say, the Puppet manifest. And then the software deployment is the thing associated with the server that triggers the configuration to actually happen. So this is kind of a visualization of how we use that within tripleo. So you create your resource group, let's say the group of controllers, and that has, let's say 3 nodes in it, configured to run in an HA configuration. You then have to go and do a bunch of cluster-wide configuration, which these are actually out of date because I removed controller bootstrap node config the other day. But the point here is that there's several passes of configuration, and ultimately we end up applying Puppet in a series of steps on each role, as well as doing some additional role-specific configuration. And that's one of the kind of things that we need to work out to enable custom roles, is kind of making all of the role configuration sequence exactly the same, whereas at the moment there are some steps that, for example, only happen on the controller, which we need to work out. But this is basically the model that is used, and when you see a deployment happening, you'll see a software deployment group go create in progress, and then you'll see a bunch of nested software deployment resources go create in progress. And typically you'll find that if one of them fails, you're then going to have to dig in and actually look at the status of the software deployment resource, the underlying software deployment resource associated with the server that had a problem. So we'll go through some examples of how to do that a little bit later once I drop out of the slides. There's not too many more. So that's kind of an overview of the basic sort of heat constructs that we use. I was then going to talk a little bit just to introduce the concepts around composable services. Were there any questions on the sort of the basic workflow before I move on? Okay, no worries. So this is kind of just a picture of what the model we had until Newton looked like. So you would pass a bunch of parameters into the Overcloud template. So the top level parent template of a tripleo deployment is overcloud.yaml. And that contains definitions for all of the resource groups that we just talked about, and all of the various post-deployment steps that we need to configure the services on the nodes defined by those resource groups. And the way it would work is all of the parameters you pass in would be passed into each of the controller nested stacks, and we would basically write out a bunch of hierodata files using a software deployment resource. And so the user provided parameters got mapped into hierodata on the file system for each of the nodes. So this worked pretty well, but the disadvantage is you had a hard-coded expectation around what services would be deployed on what role. So, for example, if you're going to have, the Heat API service deployed on a controller, we'd have hard-coded references to hierodata configuration for that. And then during the post-deployment phase, when we applied Puppet, the same problem existed. We had basically one very large Puppet manifest, which contained configuration for all of the services on the controller, but there was no way of selectively enabling or disabling services short of commenting things in the Puppet manifest and that kind of thing. So this is the model we've moved towards, which is kind of a refinement on the previous process. Here we have the exact same resource group containing nodes and the same nested stack defining the role itself. But there's a difference in the way which we define the services to be deployed. We no longer have the monolithic Puppet manifest, and we no longer have the parameters passed directly into to each role via hard-coded references in the template. So we have this thing called a controller service chain. So this makes use of a new heat resource that Jay implemented, which basically is a way of creating several resources which are a different type but have the same interface. And so we'll look at some examples of how that works in the templates in a minute. But basically it means that you can now have one heat template per service, and then you enable which services will be deployed just by adjusting a list. So one of the input parameters is now controller services, and that's a big long list of like OS tripleo Heat API and OS tripleo Heat Engine and these kinds of things. And those basically map through to Puppet Services Heat API and Puppet Services Heat Engine, for example. So it's going to be much easier from a sort of maintenance of services perspective, and it also provides a lot more flexibility in terms of enabling and disabling services on the nodes, and also if you perhaps wanted to deploy the Ceph OSD not on a dedicated Ceph node but on the compute node, which I know some folks have a requirement to do, that all becomes possible within this model, just because we've decoupled the service configuration from the role definition. So I think this is really nice improvement. It's pretty much all landed now, and as I mentioned before, the next step to make kind of like the full customizable role capability possible is custom roles. So when you combine those two, it should allow a lot of flexibility, which people have been asking for. So are there any questions on the sort of composable model before I'm going to stop looking at slides now and move on to looking at some of the templates themselves and then some sort of hands-on examples. But any questions before I go on?
Yeah, one question. So there is a way of configuring the network through JSON files. Where in the template actually that's being carried out?
To configure the network on each node?
Yeah.
Yeah, sure. Let's have a look at that. So, so this is just an example of what the composable services interfaces look like. But what I'll probably do is I'll come back to that in a minute, looking at the templates. Okay, I'm just going to drop out of the slides and bring up a terminal. So if you give me a second, then we'll have a look at the network configuration first, and then people can sort of ask if there's any other things that you'd like to see covered. In the absence of ideas, I'll go through and just talk through some of the things we looked at in more detail, and then the software deployment workflow in more detail. Okay. So can you guys see that okay? Do I need to make the text a bit bigger?
You can see the text.
Okay, great.
I think you might be not sharing the screen with your terminal on it, though.
Not again. Okay.
We see the browser.
Okay, thanks. Let's try this. Let's try this again. How about that? I've just shared the terminal. Is that working okay?
Yeah, that's working now.
Yeah.
Okay, so network configuration. So basically, the network configuration is done per node. So a minute ago, we were looking at Puppet controller YAML. So you can basically see here we've got this network config resource, and that references a nested stack, which is OS tripleo controller net software config. And then it's deployed via this OS tripleo software deployment, which is just an alias for a heat software deployment. And we pass in a couple of input values like the bridge name and a name for the Neutron public interface. If we just look at where this is defined, So we can see here, this is mapped to netconfig bridge by default. If we then look at netconfig bridge, here we can see there's basically a mapping which is passed to OS netconfig. So if people aren't familiar with OS netconfig, it's basically a Python script that takes a YAML input file and knows how to configure various things about your physical network. So it can configure network devices and bridges and bonds and these kinds of things. And so it's quite a flexible tool. It's also quite pluggable. So if there's some, maybe third-party networking thing that you need to integrate with, that can be a good place to do that. And so basically here, we've passed in this network configuration. This will be applied on all of the nodes when you deploy. This is kind of the most basic configuration. There's a bunch of other examples. So if you look in network config, so let's have a look at the multiple NICs example. You can see here, you can have an example where the box has got separate physical networks for each of the isolated networks. So we've not talked about network isolation here. That's probably a good topic for a subsequent talk. But basically, tripleo has the ability to either deploy all of the services on one network or deploy them so that they're on isolated networks. And the way you can wire this in is basically via these parameters that are passed in to the network configuration. So that's an example of multiple NICs. So here is an example of configuring if you've got VLANs configured on your switch. So you might have a different VLAN for each of the isolated networks. You would do it this way. The first example I showed wasn't configuring network isolation, so it was much simpler. These last two examples do configure network isolation. So if we go and have a look at, so a lot of the features which tripleo templates can define are enabled and disabled by basically including an environment file. So here's this environment's network isolation. If you want to deploy with network isolation, you would do like OpenStack, Overcloud, deploy minus templates -e environment's network isolation. And there might be some additional environments to do with your network configuration that you pass as well. So you can see in here, it's basically configuration for all of the different network ports and things you have for an isolated network deployment. So yeah, does that help clarify some of the sort of networking interfaces? It's a bit hard to give this extensive coverage. It might be better to have maybe Dan Snedden and Dan Prince do kind of a real deep dive on the networking side of the templates. But yeah, is that okay? It's kind of like a pointer to where most of this stuff's defined?
Yeah.
Okay, right. So let's now just have a look at the overcloud.yaml. So this is what we were kind of trying to visualize in those diagrams a moment ago. So see there's a bunch of different parameters that are passed in. The number of parameters here are kind of reducing over time because a lot of the service-specific parameters are getting moved into the per-service templates I mentioned earlier on. You can see here, this is the controller services list. So for the composable services model, which was in that diagram, basically you have a big long list of each one of these different services. And as we talked about, these are just a type alias, basically. So if we look at So here we can see, oh, that's actually disabled. That was a bad example to use. So let's have a look at, say, the Cinder API service maps to Puppet Services Cinder API. And then if we look at that, basically, here we have the endpoint map is passed in from the parent overcloud.yaml template. but these other two parameters aren't anymore. So these will basically be passed in via parameter defaults. Typically, that's going to be formatted via having an environment file. So the passwords are automatically generated by Tripleo client. And let's say you wanted to enable Cinder, enable DB purge, or okay, it's enabled by default. Let's say we want to disable it. You'd create an environment file. So you like kind of thing. So, I mean, I guess a lot of people have had experience with that workflow, but that's basically highlighting the fact that those values are no longer provided via the parent template. So the question around the order of the composable services, no, the order of the composable services doesn't matter because the ordering is defined via the Puppet profiles in Puppet Tripleo. So basically, let me just show how that works. So in overcloud.yaml, let's go through from the service list definition down to actually applying Puppet. So here's the control of services, which is basically input to this controller service chain. This is a nested stack which wraps a heap resource chain that I mentioned earlier. And basically, this is going to create a bunch of nested stacks for all of those different services. And then it's going to allow us to get basically an aggregate of all of the different configurations out. So there's two outputs, config settings, which is basically the higher data key value pairs, and then the step config, which is basically a fragment of a Puppet manifest. And what we then do is we glue all of the Puppet manifest fragments together and then apply Puppet in a series of steps. And so it's those steps which basically define the order of deploying the services, not the order of the list in the template at this time. So you can see here, service config settings, this is passed in to the controller resource group, creating a bunch of OS Tripleo controller, same as we looked at in the diagram. And then one of the inputs to this is service config settings, which is basically, that's going to be a big merged mapping of the higher data associated with each of the services in the controller services list. And if we go down a bit further, we'll see this controller nodes post deployment. So this is the phase where we actually apply Puppet. You can see that it's, again, it's an alias to a nested stack, and we pass in the role data, and that includes basically the combined manifest fragments that I mentioned as defined by a step config. We'll look at the service template a bit more in a second. And then we also pass in basically a list of all of the controller servers. So this here, servers, getter, the controller outputs has an output, which is Nova server resource. That's basically the ID of the Nova server that has been launched, which ultimately maps to the ironic node, which is one of the controllers. So let's have a quick look at how the Puppet steps are actually applied. So again, if you're not sure where one of these type aliases is defined, you can just look in the resource registry. And just basically. So it's Puppet controller post, and then we can look at that. Okay, so you can see here, there are a couple of things that happen other than Puppet in here. The artifacts config is kind of an interesting one. That allows you to basically download, say, a tarball from Swift running on the undercloud, and it will unpack the tarball via a script. So if you look at deploy artifacts.yaml, it basically runs a script that can unpack a tarball onto the local file system. I won't cover that in detail right now because otherwise I think we're going to run out of time. But it's pretty handy if you want to deploy, say, updated Puppet modules. But here's basically the steps where we apply Puppet. So we do step 1, and we pass an input value of step 1 here, then step 2, input value, step 2, etc., etc. And so ultimately we do 5 Puppet applies with a different step value. And in Puppet Tripleo, there are conditionals inside the Puppet module. So let's have a look at that. let's have a look. So this is the profile which we apply for heat engine. And so you can see in here, if step is greater than 3, we do the DB sync. And if the step's greater than 4, we have Puppet actually configure and start the services. So that's basically how the ordering is taken care of in this model. And so you can see here, this is the name of the Puppet class that configures heat, and that step value will determine the point during the deployment when things happen. So if we go back to you can see here, this is the Puppet class that we were just looking at, and this is basically what applies it. So every step in this case, this is referenced in the controller services list. Every step we're going to reapply that, but it's only going to do anything on steps 3 and 4 due to what's defined in the Puppet profile. Does that make sense? Should I cover that any more, or is that sufficient? Okay, I'm going to take silence to assume that that's all good. So we've covered the heat template model somewhat in terms of how it's all wired together. Oh, there's another question. Okay, so I think we've covered the steps sufficiently. Okay, so this pattern is basically replicated for all roles. So if you do vim puppet post.yaml, it's basically pretty much the same. The only difference to be aware of at the moment is that some roles don't apply all steps. So you can see here that the compute role actually only does step 2, 3, and 4. Before we can enable custom roles, that's going to have to be adjusted so they're all exactly the same. It's something to be aware of if you're trying to do something like hyper-converged set deployments or something. That can be confusing. So what I'll do now is I'm just going to jump onto the undercloud that I'm running locally and do a heat deployment, and we'll just dig into some of the heat interfaces and also have a look on the nodes and see the software configuration happening. Hopefully that will just help solidify some of the sort of template interfaces that we've looked at. Okay, so I've just logged onto my undercloud. I've shown you that there's nothing running at the moment. I'm just going to do, actually before I do that, there's one handy thing that people may not know about, and that is if you look in this file. So tripleo client will automatically look at a local directory of environment files. And so, for example, I've got an old image that doesn't support the latest OS refresh config commands. And so I've overridden it in my local environment by adding a file into there. That's also the way which the deploy artifacts feature works. So if you look in here, basically that's pointing to an HTTP URL. It could be anywhere, but it happens to be on the undercloud Swift. Yeah, that's the way which that all works. But let's do an overcloud deployment. So okay, so I've got a more recent version of tripleo-heat-templates, which I've SCP'd over into /tmp. And you can just reference that simply by giving a path to --templates. I'm not going to pass any environment files because other than those two in .tripleo environments, I don't need any to do the basic non-HA deployment. Okay, so this is going to start deploying, and then I'll exit out of tripleo client so we can see what's happening under the hood in a bit more detail. So by default, tripleo client just basically gives you the heat event list. You can get that same data by doing so it's basically doing the same thing that heat client does for you. But here we do heat stack list. One thing I will mention is at the moment, the post-deploy configuration is wired in by Triplo client. So if you do what I just did and Control-C out of the deployment, you'll end up with things like endpoints not being configured. But for the purposes of this, that doesn't matter because we were just going to have a look at the sequence of the configuration. So you can do heat resource list. So we can see here at the moment we're deploying the servers. So this is the resource group we just talked about. That's ultimately creating some Nova servers, which I can see from my local Vert Manager just started. And so we mentioned that heat resource group is a nested stack, so you can actually do heat resource list on that ID there as well. So you can see here, I'm actually creating a single compute node and a single controller node. So and then again, you can dig down even further if you want to look at that nested stack which defines OS triple-O controller, perhaps. Let's have a look at that. Okay, so now we see the underlying resources within that nested stack, and we can see that the server resource is still creating progress. That should go create complete in a minute as soon as the Nova server starts. And then a bunch of other things which are init complete, which is basically a non-state. It means that they've not started creating anything yet. Another way of just getting the global view of everything is to do a nested resource list. So you can do heat resource list. So you give it like a nested depth or recursion limit. I use -n5 because the default limit in the heat config is 5, so that guarantees I'm going to see everything. So there we go. We can see that the controller is still creating. So here we can see okay, so now we can see we've actually moved on to the post-deployment phase. So if we do heat deployment, we're going to see a bunch of deployments. That's another way of seeing what's actually happening. If you want to see the config that's applying, you can just grab this this ID here, config ID, the second column. You can do heat config show. And there you go, you can see that that's a script that's going to get run, and there's some which are Puppet modules and that kind of thing, Puppet manifest rather. So let's have a look on the node and see what that's actually doing. So I'm going to just SSH onto the controller node. I'm prepped for two things. OS- is because I want to see if OS collect config is running, and the -e heat is because I want to see if that heat config hook that we talked about earlier on in the slides is running. And you can see that it is indeed running. So the way which this has worked is OS collect config has collected some metadata. Oh no, I've got a load of broadcast messages. Let's do that again. So OS collect config has run. That in turn has run OS refresh config. That in turn has run the heat config script. And that in turn has then run the heat config hook associated with. So you can actually see in the previous line there was a line that looked like this: user bin ruby puppet apply, and then that's actually pointing to this file. So if we look in /var lib heat config. So when a heat software deployment happens, this is basically where all of the data goes. The metadata gets collected from heat via OS collect config, and then it ultimately ends up getting written to this directory. So this is a good place to look if you're not sure what's going on with your heat deployments and you can't figure it out via the heat CLI. And so you can see here we've got a hooks directory. So if you look in hooks, this particular image has got 2 hooks installed in it. It's got the script hook and the Puppet hook. That's just a Python script. It knows how to run Puppet. That's basically it. And then in heat config Puppet, say, you'll notice that there's these strangely named Puppet manifests. These numbers, these UUIDs, they relate to the heat software config resources that have been created. So you can see here. Okay. This is basically, you can see it's joined together, all of those per service fragments, and then Puppet's just going to apply all of those things by building a global catalog, considering all of those services and an input step value. Sometimes things go horribly wrong, and you can't figure out why it's not working. So what I tend to do is that command that I cut and pasted earlier from the CLI, the actual Puppet command, you can rerun that. You just need to basically add a step value, either via factor on the command line or via the higher data files, and then you can just rerun it locally until you've debugged what's going wrong with your manifest. So kind of worst case, if the debug loop is too long and you can't figure out what's going on by just doing the Overcloud deploy, you can log on. Particularly, this is helpful if, say, Puppet's getting stuck, you don't know why. You can run it on the CLI with ---- debug, and you'll normally figure out what's going wrong. The final directory under here is this deployed directory. So basically, this is the data that we send back to heat via heat config notify. So you'll see here, this is the metadata associated with the actual software deployment itself. You can see here, there's some input values. These are the parameters provided via the heat template. A few other things which are provided from heat, like the deploy action and the deploy server ID, and then the config itself. And then the actual notification we send back to heat is also written here. So here we go. It's got the standard out. If things go wrong, you can have a look at the standard there as well. There's some other good tips in here about debugging Puppet, which James has just mentioned on there. So that's quite a lot of information fairly quickly. Has anyone got any questions or anything else that you'd like me to kind of show whilst I'm logged into here? Okay, there is one other method for applying configuration on the nose, which we're kind of trying to get rid of, and that is there are some things that are applied directly via OS refresh config, and that uses a slightly different. So if you look in user libexec, OS refresh config, then in configure.d, there's, for example, OS net config is currently applied via an element, and the higher data is also created via an element. And you'll see here, this is the 55 heat config. This is the thing that runs all of the heat config hooks. There's a disadvantage to these running via elements, and that is that they haven't got a very good error path. If an element fails, OS refresh config goes into the error.d directory and tries to run a script. But as far as I'm aware, there's no way to tell which element failed, and definitely not kind of. So therefore, we can't really signal error back to heat. For that reason, we're probably going to move away from this model, but it is still in use in the templates at the moment. So the method there is basically say let 20 OS net config will run, and again that's just a shell script. So if things are going wrong, you can log on and run that manually, which can be a good way to find out why it's all going wrong. Providing OS net config isn't actually breaking the network, in which case you'll need primary console access. Then if you look in postconfigure.d, there's this script called 99 refresh completed. And basically, this does the same thing as heat config notify, only as I mentioned, it doesn't know how to signal when there's been a failure. So this is kind of the legacy model that we are using, but trying to get away from. So sometimes you'll find if maybe networking is broken, this script can't signal back to heat, and then everything will hang, and you won't get things proceeding through the deployment. Or if there was a bug in one of your elements and one of those scripts just stalled forever, that would be likely to cause problems as well. So again, you can tell a lot by doing PSAX, seeing what scripts are running, and then kind of figuring out which part of the deployment is causing you issues. So going back onto the Undercloud for a minute. This is still going. There's another quite handy interface that I'm aiming to wire into tripleo client, which landed quite recently and people might not know about. If you do OpenStack stack failures list, Overcloud. Okay, at the moment there are no failures, but in a minute, if we have time, I'll modify the templates and cause the deployment to fail. And at that point, you can basically do OpenStack stack failures list, and it will dump out the standard error for the deployment that failed and any other information related to the failing resources. I think we should surface that data by default via tripleo client, but as of right now, that's kind of, if you're on an up-to-date heat client version, that's something you can make use of. Okay. The other thing is, having looked at kind of the node side of the software deployment workflow, if you do heat you can actually look at the software deployments themselves. So in this case, we've got these. I think we're actually using an alias for the deployment, so I might need a different grep string, but let's look at these anyway. If you do heat deployment show, you can see here, this is another way to get at that information that is signaled back to heat. So you can see that we've got the standard out, there's not been any errors, and the exit code was 0. So this is typically the first place I look when a stack create or update fails. You need to figure out the deployment resource that failed, and then have a look at the deployment show output, or OpenStack stack failures list, as I mentioned on recent builds, will basically do the same thing. Okay, so that's now created. We can maybe cause that to fail. So when you want to do an update of an Overcloud, all you really need to do is run the same command again. So even if it's in a failed state, you can just keep running the Overcloud deploy command. So I'm just going to run this again. I've modified that heat engine file so it should fail. And this is going to go through, and rather than doing a create, it's going to just walk the same templates, and it's going to update everything. So I'll let that run for a moment, and we'll wait for it to fail, and then we can hopefully just go through the ways that you can surface the reason why it failed. Okay, we've only got 2 or 3 minutes left, so whilst that's just going through and getting ready to fail, has anyone got any remaining questions?
There's a question in the chat.
I can't read that because it's just off the bottom of my chat window for some reason. I think my screen.
Can all variables defined in the Puppet class be set via environment file? I think the answer is yes, via the higher data override.
Yeah. There's basically a controller extra config override, so we can show how that would work. So let's have a look at in here. Let's say I wanted to override this heat workers parameter. So you would expect to pass the parameter heat workers, really, but there's basically two ways that you could do that. So that's one way of doing it, and that will take precedence over the parameter value that is set inside the template, or you could just do those two are basically the same. Obviously, the advantage of the controller extra config interface is if there's some higher data that we don't surface via a heat parameter, which is quite a lot of them, you can pass that data directly through to Puppet via that interface. The disadvantage of controller extra config is it doesn't fit so well with kind of the Composable model. So let's say you decided to run heat engine on your Ceph storage node. I don't know why you'd do that, but let's say you did. At that point, the controller extra config won't work. You would need to pass it in via Ceph storage extra config. But that's something which you're going to have knowledge of as a deployer. If you move things around, you would have to adjust your extra config overrides accordingly. But yeah, basically, this is the way which you can pretty much set any variable available via the Puppet module interface. Okay, we are pretty much out of time, but let me just see if that has actually failed. No, not yet. Okay, well, never mind. We can. I'll leave that as an exercise. Are there any other questions before we wrap things up? I assume people have probably got other meetings and things that they need to get to, so we probably shouldn't run too far over.
Yeah, great. Thanks, Steve. That was really good.
Okay, well, I hope that was helpful. Feel free to sort of, catch up with me on IRC afterwards if anything requires clarification or didn't make sense. Also happy to kind of take requests for blog posts and things, or even sort of docs patches. I'm happy to help with those if there are things that people need, additional info on.
And please don't forget to put your ideas for the next deep dive on the Etherpad and +1 stuff you want to see, and we'll try to get a topic picked out, by Monday or Tuesday or so of next week. All right. Thanks a lot, everyone.
Thanks, everyone.
Thank you, guys. Yeah.
Thank you.
Cheers. Thanks.